Hi everyone. Today we're going to start the topic on atom. So we're going to kick off with John Dalton's atomic theory. In the beginning of the 19th century, John Dalton has these 5 propositions. First is that all metal contains atoms, and all atoms are indivisible, right? And atoms of the same element share identical properties like mass. Atoms of different elements have different mass, and atoms combine in fixed whole number ratio to produce compound. So let us evaluate each of the statement and see whether it is still valid today. Indeed, matter still is made up of atoms, all right? So this is correct. As far as atoms being indivisible, that is no longer true. Now that scanning electron microscope, we also understand that atoms is now made up of proton, neutron, and electron. Atoms of the same element share identical properties like mass. That is not correct as well, because we know that there's actually isotope, and isotope has varying mass depending on the number of neutrons that they have. Atoms of different elements have different mass. The statement is not correct, since you may have potassium with a mass number of 40, as well as argon with a mass number of 40. Finally, atoms combine in fixed whole number ratio to produce compound. That is correct. That is actually how we now balance our equation using this concept. Now let's take a look at how the subatomic particles, neutron, electron, and proton behave in an electric field. All right. So what's happened as far as neutron is concerned, it is actually beamed through the electric field, but you can see it passed through undeviated because it does not have a charge. Quick recap is that the 1 represents the mass number, the 0 is actually the charge of the particle, or the number of protons that it has. Obviously, it has none. So in the case of electron, it's -1. In the case of proton, it has actually 1 proton and its mass remains at 1. And obviously, electron has a merely negligible mass. That's why the mass is represented as 0. Okay? So there's a formula that you need to use for this calculation. So theta is directly proportional to the so there's actually a formula that you need to know for your calculations. So angle is directly proportional to the charge of the particle divided by the mass of the particle. All right. So you can clearly see that the angle theta, all right, theta is much larger than alpha. Okay. The reason for that, if you were to calculate the Q over M for this, you realize that it is actually -1 divided by 0, which means it goes to infinite. So the angle is going to be much larger, all right? Whereas for the case of Q over M, for the case of proton, it will just be 1, all right? And clearly, in the case of neutron, the Q over M is actually 0. So you can see it pass through undeviated. Let us consider one example. Say actually we have an alpha particle, or otherwise what we term as a helium nucleus that will need to pass through. So let's take a look at the helium nucleus. It's actually He, and it's actually a 4-2, and it's actually 2 positive charge. All right. So for the helium nucleus, you realize that the in terms of its Q over M, so it will be 2 over 4. So that will give us half. And therefore, because of that, it means that if I let the angle that it actually so it's going to get deflected this way. So the angle it get deflected will actually be somewhat traveling along here. It will be half that. Okay, so it's 4-2 He2 plus. This angle will be alpha over 2. It will be half of this angle because basically the Q over M value is 1, and that's directly proportional to alpha. So if I only have half, Q over M value is half, then the angle that you will get deflected will be alpha over 2.